Hello everyone, my name is Nicola Arnoldi and I'm a solutions architect here at AWS. Today I will be demonstrating how you can use the AWS Transit Gateway to enable networking between VPCs across AWS regions. We will start by quickly describing the scenario, and then we will recap some basics of Transit Gateway that will come in handy during the actual demo. We'll then move on to a description of our design and then end with the demo in the AWS Management Console. For the purpose of this demonstration, I will cover a scenario where you have 3 VPCs in 2 AWS regions: production, staging, and shared services. Each of these VPCs is configured in a different AWS account. What we want to do is to enable networking across regions between VPCs so that workloads in the production VPC in one region can reach workloads in the same VPC and account in the other region. The same applies to the staging VPC. The shared services VPC is used to deploy services that are consumed by both the production and staging VPCs in the same region. To make this possible, we need to enable networking between the shared services VPC and the local production and staging VPCs. In our scenario, we also take into account that in our organization, we have a networking team whose responsibility is to look after the AWS networking. This is an organizational pattern we often see with customers, which is why I think it's important we reflect that in this demonstration. We will configure the transit gateways required in our demo in a separate network account and share them appropriately with other accounts in a controlled and secure way. But before we dive right into the demo, let's do a quick refresh of the basics of Transit Gateway. Transit Gateway is a regional service that can be seen as a highly scalable and highly available cloud router that helps you simplify the way you manage your AWS networking by putting an end to complex VPC peering relationships. Transit Gateway also simplifies the network configuration if you need to enable hybrid networking between your on-premises facilities, such as a branch office or a data center, using site-to-site VPN and Direct Connect by consolidating all those connections in a single place. At reInvent 2019, we introduced inter-region peering, a feature that allows you to enable networking across regions using the AWS Global Network. Whenever you connect a resource to a transit gateway, whether it's a VPC, a site-to-site VPN connection, a Direct Connect gateway, or a remote transit gateway, you create what we call a transit gateway attachment. Whenever packets are sent from an attachment into transit gateway, the transit gateway makes a forwarding decision by performing a route lookup operation in one of its route tables. A transit gateway route table tells transit gateway which attachment to use to send packet for a specific destination. For example, if a packet is received by transit gateway from attachment D and has a destination IP of 10.0.0.9, transit gateway will look into its route table for a match. A match with attachment A as a next stop is found, and the packet is then sent onto attachment A and delivered to the right VPC. One of the ways Transit Gateway provides flexibility in the way you can design your cloud networking in AWS is by allowing you to have multiple route tables. By having multiple route tables, you can identify and create multiple routing domains so that you have more granular control over how packets received from each attachment are handled by Transit Gateway. Each attachment is associated to one route table. What this means in practice is that whenever Transit Gateway receives a packet from an attachment, it performs a route lookup operation in the route table that is associated to that attachment. For instance, let's say that you have a packet coming from attachment A into Transit Gateway with a destination IP of 10.128.0.224. Transit Gateway will use route table X to find out which attachment to send the packet out from. A match is found and the packet is sent onto attachment D. If we keep looking at this example, if we had, for instance, a packet coming into attachment A with a destination IP of 10.2.0.18, a route lookup in the route table associated to attachment A would not find a match, and therefore the packet would be discarded. The last basic concept of Transit Gateway that we need to discuss is the so-called propagation. The question that we are asking ourselves now is, how are my route table entries populated? There are two methods you can use to make sure your Transit Gateway route tables have all the entries they need for Transit Gateway to be able to route packets the way you want it to. The first way is by adding routes manually into your routing tables. In our example, I manually add the route to 10.128.0.0.16 via attachment D to our route table VPC. The second method that you can use to add routes to a Transit Gateway route table is by propagating attachments. Each attachment comes with routes that can be installed to one or more Transit Gateway route tables. When an attachment is propagated to a route table, these routes are dynamically installed in the route table. But how does all this fit into our scenario? Let's go and have a look at our network design. The setup that we have in both regions is pretty much identical, so I am going to cover just EU West 1 on the left-hand side of the screen. There we have 3 VPCs, each owned by a different AWS account. All of them are attached to a Transit Gateway, which is owned by a different AWS account controlled by the network team. The Transit Gateway has 4 route tables, 1 per attachment. We need that because all 4 attachments have different network reachability requirements. The production VPC needs to access the local shared VPC and the remote prod VPC. The staging VPC needs to access the local shared VPC and the remote staging VPC. The shared services VPC needs to access the local prod and staging VPCs. Finally, the inbound traffic coming from the inter-region peering attachment needs to be able to be routed to any of the local VPCs. Now that we have discussed the basic concepts of Transit Gateway and covered our network design, let's head to the AWS Management Console and see how this is all put into practice. To save some time, I already created 1 VPC per region in every account, and I deployed 1 EC2 instance in each VPC. We will use those to demonstrate connectivity between VPCs, both intra and inter-region. We now have to create our Transit Gateways in the network account in EU West 1 and EU Central 1. So let's head over to the blue browser tabs that correspond to the network account. We go on VPC, Transit Gateways, and choose Create Transit Gateway. When you create a Transit Gateway, you need to specify some options. We start by giving our Transit Gateway a name, TGW EU West 1. The next thing we need to configure is the Amazon site AS number. For this Transit Gateway, we can leave the default option, that is 64512. We strongly recommend choosing unique ASN for different Transit Gateways, especially if you plan to peer them. The next 2 options that we need to configure are the default route table association and propagation. When those are enabled, as soon as an attachment is configured on a Transit Gateway, this attachment will be associated and propagated to a default route table. These 2 options are very useful if you want to implement a simple networking design with Transit Gateway. In our case, we need to have a bit more control over our routing by creating multiple route tables. We therefore uncheck those 2 options and finally select Create Transit Gateway. I will now complete the same process in EU Central 1. So we go on VPC, Transit Gateways, and choose Create Transit Gateway. We give this a name, DGW EU Central 1. We pick a unique ASN, such as 64513. We uncheck the default route propagation and association options and select Create Transit Gateway. Okay, so now we have our Transit Gateways created in both regions. The next step is to share these Transit Gateways with the 3 accounts whose VPCs will need to attach: production, staging, and shared services. To share a Transit Gateway, we will use Resource Access Manager, so let's do that. In the network account, in EU West 1, we go on Resource Access Manager and create Resource Share. We give this share a name, such as TGW Share EU West 1. We select the resource type, Transit Gateways, Once we do that, the transit gateway that we just created appears in the list. So let's select it. The last thing we need to do is to list the principals that we want to share this resource with. I previously took note of the account IDs of our production, staging, and shared services accounts. So let me paste them in. This is production, staging, and shared services. When you create a resource share with Resource Access Manager, an invitation is sent to the principal you share the resource with, unless you share that resource with your AWS organization, in which case principals are granted access to the resource without having to accept an invitation. In our case, we are not sharing our transit gateway with an organization, so let's find out how we accept the resource share in our accounts. Let's start with the production account and go into the AWS Resource Access Manager console. In the navigation pane, we choose Resource Access Manager. And let's have a look at the resource share that I have invitations for. I select the TGW share that the network account just shared with this production account and go ahead and accept it. Once the production account accepts this share invitation, if we go on the VPC management console and choose Transit Gateways, we see that the transit gateway we created in the network account is now showing up. The console indicates that the owner of this TGW is another account ID. In fact, if we try to delete or share this transit gateway, we see that we are not allowed to do that. This is because we do not own this transit gateway, but it was just shared with this account. We have to repeat this process of accepting the RAM share in the staging and the shared services account. So let me do that really quickly. This was staging, and this one in yellow is shared services. The steps that are demonstrated so far for EU West 1 will need to be repeated for EU Central 1. I will pause the video while I do that and resume when that's complete. We now have created transit gateways in EU West 1 and EU Central 1 and share those with the production, staging, and shared services accounts in both regions. What we have to do now is to configure the inter-region peering attachment between the transit gateway in Ireland and the transit gateway in Frankfurt. To do that, we navigate to the VPC management console of the network account in the EU West 1 region and select Transit Gateway Attachments and choose Create Transit Gateway Attachment. The first thing that we need to do there is select the transit gateway that we want to peer. In EU West 1, we just have one transit gateway, which we created a moment ago. The attachment type is going to be peering connection. We give this attachment a name. The region that we want to peer with is EU Central 1. Finally, we have to indicate the transit gateway ID that we want to peer with. So let's go on the VPC management console in EU Central 1, which is VPC transit gateways, and we copy the transit gateway ID in EU Central 1. Let me paste that in the creation process, and we finally choose Create Attachment. The attachment will move in just a few moments in a pending acceptance state. This takes about a minute. What this means is that we will need to head over to the VPC management console in the acceptor region, which is EU Central 1, and accept this peering attachment there. Let me refresh the browser a few times until the request goes in a pending acceptance state. Okay, so now the attachment is in pending acceptance. I'm now in EU Central 1. If I go on Transit Gateway Attachments, I see that it's there. So I will go ahead and accept it. I will give this attachment a name, Inter-Region Peering EU West 1. The attachment takes a few minutes to become available, so we'll stop the video and resume once that's done. Nice, so we now have our transit gateways shared with our accounts and paired with one another. The next step is to attach the production, staging and shared services VPCs to the transit gateways in EU West 1 and EU Central 1. I will demonstrate this procedure just for EU West 1 and the production account. So I navigate to Transit Gateway Attachments, select Create Transit Gateway Attachment. I specify the ID of the transit gateway that I want to create the attachment on. I give this attachment a name tag. And select the VPC that I want to attach to my transit gateway, which is the production VPC. Whenever a VPC attachment is created, Transit Gateway deploys elastic network interfaces in one or more subnets that belong to that VPC. As for most of our well-architected best practices, we recommend choosing more than one availability zone. In our case, I will leave everything as it is and choose all 3 subnets in my VPC and create the attachment. Earlier, when we created the transit gateways, we left the auto-accept shared attachments option disabled. This means that the owner of the transit gateway needs to approve the attachments being requested by other principals. So we will need to go to our network account in the transit gateway attachments console, refresh our page, and accept the attachment that we just requested from the production account. When you create an attachment and give it a name tag, that tag is visible just to the account that created the attachment. In fact, I will need to replicate that tag in the network account just for consistency. The attachment will just become available in a few minutes. But how do the subnets in this VPC know how to route network traffic to the transit gateway attachment? Let's have a look at the route table associated to them. So in the route table, we have just the local route for the VPC CIDR range. If we want packets to cross the VPC boundary and be delivered to any other VPC, we will need to add to our route table a route for the 10.0.0.0.8 range, as all the subnets in our design fall within this rather wide range. Doing this won't break the routing between subnets in this VPC, because a more specific local route is already present in the route table, which takes precedence over the more generic routes that we are adding. So let's go ahead and add the route for the 10.0.0.0/8 range. We go on Edit Routes, select Add Route, add 10.0.0.0/8 as a destination, and choose the transit gateway as a target. And choose Save Routes. Okay, so that's all done. I will now stop the video, repeat this for all the VPCs in all the accounts in both the EU West 1 and EU Central 1 regions, and check back in when I'm done. Okay, so we now have our peer transit gateways attached to the VPCs. The last thing we need to do before we test our network is to configure the routing on our transit gateways. Let's start by doing that in the EU West 1 region. So I am in the network accounts in Ireland, and I will go ahead and create the routing tables. To do that, I navigate on VPC, scroll down to Transit Gateway Route Tables and choose Create Transit Gateway Route Table. I'll start by creating the production route table associated to the production VPC attachment, and I select the Transit Gateway ID. And I choose Create Transit Gateway Route Table. Now I'll go ahead and repeat this process for the staging, shared and inter-region route tables. This is staging. This is the shared route table. And the last one is the route table associated to the inter-region peering attachment. Okay, I have now my routing tables. What I need to do next is to associate the attachments to those route tables. So I select the production route table. I go on associations, create association, and choose the appropriate attachment that I want to associate to this route table, which is the production VPC attachment. And I repeat this process for all the other route tables. So this is staging, create association, select the staging VPC attachment. Let's do shared next, create association, shared attachment, and finally the inter-region route table association. What I will do next is to configure routing by propagating attachments in our route tables and adding manual routes where appropriate. Let's start by looking at the route table associated to the production VPC attachment. As you can see, there is no routes at the moment. As per our design requirements, we know that our production VPC needs to be able to send and receive traffic from the local shared VPC and remote production VPC. To accomplish that, we first propagate the local shared services attachment and add a static route for the remote production VPC. I select Create Propagation, Shared Services Attachment, and I go ahead. I then add the static route for the remote production VPC. I go on Routes, Create Static Route. For CIDR, I input the remote CIDR for the remote VPC 10.128.0.0/16, and I choose the inter-region peering attachment. And I choose Create Static Route. We would also like to ensure any other network traffic is actively dropped by Transit Gateway, and to do that, we add a 10.0.0/8 black hole route. I go on Create Static Route 10.0.0/8, and I select black hole and create static route. We now use a similar process for the staging route table. We propagate the local shared attachment and configure the remote ranges 10.129.0.0/16. The next stop is going to be the inter-region peering attachment. I create a static route and then the black hole route. Okay. For the shared route table, I just propagate the local staging and production VPC attachments. That's production. And I need to propagate staging and create propagation. And I need to do the same thing for the inter-region route table. I want all the incoming traffic from the inter-region peering attachment to have the possibility to reach the production staging VPCs. Okay, that's me done in EU West 1. I will now stop the video, configure the Transit Gateway routing in EU Central 1 and resume the video once that's done. Welcome back. We've finally come to the last part of this demo, where we find out if the network design we implemented with Transit Gateway fulfills our requirements. To do that, I will log on via Session Manager on the EC2 instance I pre-deployed in our production account, and I will ping the IP addresses of other instances in other accounts and VPCs, both within this region and across the inter-region boundary. So I am now in the production account in EU West 1, and I navigate on EC2. I select Running Instances and choose Connect. As connection method, I pick Session Manager and select Connect. In a few seconds, the Systems Manager, Session Manager session appears on screen, so I'm ready to start pinging other IP addresses. The first IP address that I will start pinging is the shared services instance in this region. So let me do that really quickly. Let's ping 10.2.0.94. And this works. Let's try to remember what our network design should be. The production VPC should be able to talk to the shared services VPC in this region, and this works. The next IP address that I will ping is the staging instance, and this should not work. It's 10.1.0.2.1.1. As we can see, this does not work. The next instance that I will ping is the remote production VPC instance. So ping 10.128.0.163, and this also works. We can see that the latency is a bit larger than the ones that we've seen before. And let's finally try to ping the remote shared instance, which we should not be able to ping. And this doesn't work. Now I could go on and demonstrate all the other permutations, but I've decided to leave that to you. Thanks for making the time for watching this demo, and I hope I gave you some inspiration to go ahead and try inter-region peering on the AWS Management Console, API, CLI or SDK. And thanks for watching, and keep on building.